Here is a pentagon. I've colored the base of the pentagon red, and I've also colored a line between the two vertices above it red. These two lines must be parallel, because flipping the pentagon, if they intersected, it would move the intersection point to the other side. But flipping the pentagon doesn't change either line, because it doesn't change the pentagon. Likewise, these two blue lines are also parallel. Notice that the blue lines and the red lines have to be the same length, because one of the red lines is one of the bases of the pentagon, and one of the blue lines is one of the bases. So here we have a parallelogram, and all four sides are the same length. Here's a pentagram. Hipassus wanted to put dots on the pentagram, equally spaced, so that there would be dots at these corners where the different types of lines intersect. It's equivalent to saying that there's some integer, so there are two integers, so that one length can be represented by one integer and the other length can be represented by another integer, and the ratio between the two lengths, a quotient of two integers, is rational. But instead of talking about rational, you can just imagine you have to have equally spaced dots that meet up with the corners. Now, if you put two pentagrams next to each other, see the little point coming off it, the light blue lines. The little points coming off of one pentagram stretch across the other pentagram. So the length of the point is the same as the length of the sort of meridian. That means because it's the same, that since we've been able to put equally spaced dots along the point, in this case 1, 2, 3, 4, 5, we'd also be able to put 5 equally spaced dots along the meridian. And using their parallelogram, we'd also be able to put 4 equally spaced dots along that little blue line that's the same length as the red line and parallel to it. And what that means is we'd be able to put equally spaced dots on the small blue pentagram, and you see the shorter blue leg, and we put 4 dots on it that was parallel to that red leg, exactly shows that one of those dots lies on that corner intersection. So once you put dots on the longer and shorter leg of the smaller blue pentagram, we can continue on and put dots everywhere on the smaller blue pentagram with dots on the corners. Now, I haven't done it. In fact, I haven't been able to do it, so something went wrong with, must mean that my dots on the red pentagram must not have been correctly done, must not have actually been equally spaced, because if the dots on the red pentagram had been equally spaced, the dots on the blue pentagram would have landed right on the corners. We could have gone on forever. However, if you look at the little blue pentagram, there's a pentagon inside that, and going forever would mean filling up a little star inside that and a little star inside that, until we'd be filling up stars with black dots where the size of the star is even smaller than the distance between the dots. That's totally impossible. By the way, one thing to look at is notice that the pentagon has a smaller, the USA pentagon has a smaller pentagon in the middle of it. But in order to represent Hipparchus's proof, it should have been an upside-down pentagon. So the US is, of course, in their typical way, simplified an idea to the point of absurdity. But just looking at the big pentagon and the little pentagon inside it, you see once you put equally spaced points along the big red star, because the longer and shorter side of the blue star are the pointy length and the difference between the pointy length and the distance, well, because both the lengths in the blue star are segments in the red star. Once we put equally spaced dots on the red star, we would have put equally spaced dots on the blue star. That's the impossibility. And it used the two theorems. The one is that the pointy length is the same as the meridian length, and the other that because of this parallelogram business, the extent across the pointy length plus one of the sides of the smaller pentagon is the same as one of the sides of the larger pentagon.